Hello. So today we are going to do physics paper 2 multiple choice questions. So let's do this together. We're going to look at the Eastern Cape paper 2 June exam. So we're just going to be chatting and discussing how to cancel out multiple choice questions. So it's going to be a sort of a learning curve, or we are learning. We're trying to answer questions and we are learning too. So we're going to do the multiple choice from question 1.1 to 1.7, I think. So let's do this. So the first question says, the homologous series that contain a carbon-carbon triple bond. So it's basically asking for the homologous series that contain a carbon-carbon triple bond. Carbon-carbon triple bonds are carbon, and then you have your 3 carbons to another carbon. So let's look at the options that we are given here. So you have alkanes. Alkanes are carbon, single bond, carbon. And then you have alkenes. Alkenes are carbon, double bond, carbon. And then alkynes are carbon, triple bond, carbon. Then you have haloalkanes. Haloalkanes, you're looking at halogens. So you have your carbon and a single bond to a halogen. It could be a chlorine or a bromine, any halogen. So when we're looking at halogens, we're looking at group 7 in the periodic table. So the question is asking for a homologous series that contain a carbon-carbon triple bond. That is option C. So the correct option is alkynes. So let's move on to another question. Let's do question 1.2. Question 1. So question 1.2 says, consider the following compounds. So you have pentane 1-ol, butane 1-ol, pentanoic acid. So the question says, which one of the following correctly rank the above pure substances in the order of increasing strength of intermolecular forces? So let's look at the keywords here. One is asking for the ranking, so of increasing strength, in order of increasing strength. What does that mean? It means we need to start from the one that has a very low strength to high strength, right? And then how do we monitor that? So you have 2 alcohols and then a carboxylic acid. So you have your C double bond O with an OH, right? And you also have your 2 alcohols. The other one is pent, the other one is but. So the other one is butanol, the other one is pentanol. So what does it say about the strength and the chains? So the first thing that you need to know is how is the strength of a carboxylic acid compared to that of your alcohol. So for the carboxylic acid, you have those 2 oxygens. So you have this oxygen, and another oxygen here. So you have this oxygen and oxygen. So this one, the intermolecular forces of this one is very strong. This one is very strong. And for the alcohols, we have just C and then Jesus. So question 1.2 is we're looking at the strength of our substances. So you have your alcohol, pentane 1O, then you have your butane 1O and another pentanoic acid. So the strength of, how is the strength of carboxylic acid compared to that of alcohols? We know that carboxylic acids are stronger, have stronger intermolecular forces than alcohols. The reason why that is because we have 2 oxygens in our carboxylic acid. So you have this C and then double bond O. Sorry about that. You have C double bond O and then your OH. So these are very strong withdrawing groups. And then we have your C and just one OH, right, from the alcohols. So you have this oxygen here, and then here you have 2 oxygens. So this one is stronger than the other one. So now you need to also compare your alcohols. The other one is pent and the other one is bute. So moving from, the question is asking in order of increasing strength. So you start from the one that is weaker and then go on and on. So the only difference is that you have your bute and pent. Bute is 4 carbons, pent is 5 carbons. So the correct answer for this question is D, where we end with you start with the one with 4 carbons and then with 5 carbons, and then we go to the one which is stronger with 2 oxygens. Okay, let's move on to the next question. So the next question is asking us to consider the structural formula here. The structural formula has a carbon here. Let's just take this as an R group. It could be, this is an R group, it could be a carbon, so, or a carbon, let's say it's a carbon. So you have your carbon and then your carbon double bond and then your hydrogen. And then the question says, which one of the following compounds contains the above functional group? This functional group that she's given here. So you have propanol. Let's start at the end. So you have option D, which is propanoic acid. Propanoic acid, you have your C double bond O, and then your OH. It's a carboxylic acid, oic acid, right? And then here you have your C or R group like this. So it's not the same as this one that is given here. And then your propane 1O. For your propane 1O, you have your carbon, and then your OH, right? Then your OH, right? And then and your OH. Sorry guys, I think I'm pressing something here. I'm not sure what it is, but I'm pressing something that I'm not supposed to be pressing. Okay, let's just fix that. Let me pause this. And then option B, you have propanone. Propanone, that's an ketone. That's a ketone. So propanone, you have your, I just want us to look at this functional group. So propanone, you have your C double bond O, this carbon, and then another carbon on the side. So it's different from this one where you have a hydrogen this side, but this one propanol. So it all goes into knowing how to name and what functional group that is. So enal is an aldehyde, right? And an aldehyde, you have your hydrogen in your carbonyl group and then a carbon, whatever. So the chain goes on. Let's move on to the next question. So the next question is 2-methylpropane 1-ol can form two isomers. Which one of the following combinations correctly identifies the isomer and the type of isomer? So I think what we need to know first is the different types of isomers. So positional isomers is just you may be moving a functional group like an OH along, right? So from this position to another position, that's a positional isomer. A chain isomer, you have your 4 carbons and then you taking one of the CH3 and changing the chain to have a branch or something, right? And then your functional isomer, you are changing the functional group. If you had, for example, if you had an aldehyde, you're changing that thing to a ketone, right? And then positional we've explained. So the first thing that you need to know here is to know how to draw 2-methylpropane 1-ol to see how the isomers can be. So how do you draw the 2-methylpropanone? So you have your the longest chain is propane. Propane is 3 carbons, right? You have your 3 carbons, and then the functional group is ol, which means it's an alcohol. And on the second carbon of your 3 carbons, you have a methyl there. Why is it zooming out? You have your methyl there, right? And then you have butane 1-ol, butane 1-ol. You have now 4 carbons and an O. What is the molecular formula for 2-methylpropane? You have C4. So it's C4. You have 4 carbons there. It makes sense to have butanol, right? So is it a positional isomer changing from 2-methylpropane 1-ol to butane 1-ol? Is that a positional isomer? I don't think so. I just think it's a chain isomer. And then B, you have 2-methylpropane 2-ol. So now you are moving the OH to the position 2 while it was at position 1 here. Is that a chain isomer? I don't think so. I think it's a positional isomer. And then option C, you're having a butanol again. Is it a functional isomer? No, it's still an ol, so it's still an alcohol. And then option D, you have 2-methylpropane 2-ol. Is it a positional isomer? Yes, you've changed 2 and 1. You've changed the position.